I want to go over a few of the slides that we didn't get a chance to get to last night. Starting with slide number 52, it was a U-try, and it says b squared plus 13b plus 42 equals 0. We had quickly put that up on the board, and we had gotten the answers of -6 and -7. And we had used the quadratic formula. So again, just a quick reminder, we had negative b plus or minus the square root of b squared would be 169 minus 4 times a times c all over 2 times a, which would just be 2. And that gave us negative 13 plus or minus 1 all divided by 2. Again, this piece right here, guys, I don't mind if you do on your calculator, so feel free to pull that calculator out to crunch those numbers. So we end up with two solutions, negative 13 plus 1 divided by 2 and negative 13 minus 1 divided by 2. And that's where we got negative 12 over 2 and negative 14 over 2, and that's where negative 6 and negative 7 are coming from. And that was actually on slide 49. So I just wanted to do a quick review of that. Then I want to jump to 52. And on slide 52, it says, let's try some. X squared minus 3x minus 4 equals 0, and it says this one factors easily. So remember, we're looking for two numbers that multiply to the last term, that add to give us this middle term here, and those factors are going to be negative 4 and 1. So that factors to be x minus 4, x plus 1, and then you need to set each factor equal to 0. So I'm going to set x minus 4 equal to 0 and x plus 1 equal to 0. I'll add 4 to both sides. That's why this becomes x equals 4. I'll subtract 1 from both sides, and that's where I'm going to get x equals negative 1. On the next slide, we have y minus 4 squared, quantity squared, equals 11. So I'm going to take the square root of both sides because I have a squared term sitting on one side of the equation. So I get y minus 4 equals the positive or negative root of 11. I'll add 4 to both sides, and I get y equals 4 plus or minus the square root of 11. And that was slide 53. Slide number 54 is sort of a messy looking problem. It's 6x squared plus 11x minus 35 equals 0. And if you read that slide, it says this may factor, but it looks like it would be a fair amount of work, and I'm feeling a bit mindless and lazy, so I'm going to use the quadratic formula instead. So remember, we've got a, b, and c. And the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And I'm just going to plug my numbers in. So I get negative 11 plus or minus the square root of b squared is going to give me 121 minus 4 times a times c. And just be careful with c because c is negative 35 all over 2 times a, so that gives us 12. And again, use your calculator to crunch that number out. You'll end up with negative 11 plus or minus the square root of 961 all divided by 12. And that's going to give you negative 11, you can use your calculator, plus or minus 31 over 12, so I've got two solutions, negative 11 plus 31 divided by 12, and negative 11 minus 31 divided by 12. And then you can go ahead and simplify from there. On the next slide, it says let's do a few more. This is slide 55. You've got 6r squared plus r equals 1 I'm going to subtract the 1 because I need it set equal to 0. And I would suggest go ahead and seeing if this factors. It will, so this is a nice time to review how to factor when the leading coefficient is not a 1. When I multiply my first and my third term, I get negative 6r squared. So I'm looking for factors of negative 6 that are going to add to give me 1. So that's going to be 3 and negative 2. And remember, it's these numbers that I'm going to replace this middle term with. So I'm going to bring down my first term. Now rather than r, I'm going to say, well, 1r is the same as 3r minus 2r. I'm going to bring down that last term and then factor by grouping. So I'm going to pull out a GCF. So what can come out of these two terms? I can pull out a 3r, and then I'm left with 2r plus 1. And we had talked about anytime there's a leading negative, that means a negative needs to come out. So I'm going to pull out a negative 1. Now I've got these guys in the parentheses matching. So I've got my two factors of 3r minus 1, 2r plus 1 equals 0, and when you set each of them equal to 0 and solve, you will get 1/3 and negative 1/2. On that very slide, you've got r minus 2 squared equals 7, and this is an example where I would take a square root of both sides because I've got a squared term sitting on one side by itself. So I get r minus 2 equals the positive or negative root of 11, and then all I have to do is add 2 to both sides. So I get 2 plus or minus the square root of 7. And then the next slide that I really needed to give you the answers for, we had 4k squared plus 2k equals 1. You're going to want to move that 1 over. So we get 4k squared plus 2k minus 1 equals 0. And you can go ahead and try to factor. As soon as you do, though, you get a negative 4k squared. And there aren't two factors of negative 4. They're going to add and give you 2. So at that point, you're going to want to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a, which will be 8. Okay, so you can go ahead and crunch the numbers from there. You'll end up with negative 2 plus or minus 2 times the square root of 5, all divided by 8. And remember, when we were in class, we said, well, look at these numbers here and make sure that they can't be simplified. These can. 2 goes into all of them. So these are going to become a 1, and that's going to become a 4. And then on that same slide, let's go ahead and make that black. We've got r squared equals 3r plus 5, so I'm going to move them all to one side. So minus 3r minus 5 equals 0. Right away I notice I can't factor it because there are not two factors of negative 5 that will add to give us negative 3. So I'm going to use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, use your calculator to crunch that, and you're going to get 3 plus or minus the square root of 29 all divided by 2. The only other slide that we really didn't get to was that last slide, and we got to it, but we didn't go over the answers. So slide 15. The last slide that we talked about but didn't completely get to was asking the height of the building is 1,217 feet. How long would it take for an object to fall from the top? Or how long would the object fall? Or how long would it be in the air? And I don't think I did a very good job of explaining this, and I may have even confused you even more than you needed to be. Both of those bullets are asking the same question. We're going to go ahead and plug in 1,217 in for S, because that's how high it is. So then we're going to figure out how long it takes for the object to fall that distance. So we end up, this is a calculator problem, with 76.0625 being t squared. We'll take the square root of both sides, and we end up with about 8.72 being how long the object is in the air. I think that was the only slides that we didn't really get to that I at least wanted to show you the work for, talk through it with you together. If you have any questions, please don't hesitate to email me or call me during the week. Have a great week, and I will see you all in 2 weeks.